Okay, ladies and gentlemen of calculus, we went over this problem last Friday where we looked at what was happening. In fact, I think what we did is I recommended stacking these number lines one on top of the other.
Yes,
to just,
in a room, I remember.
yeah, just see what was happening. And we learned something about number lines last week, right?
They're your friend.
That they were our friends, right? And what else we learned, Hannah, that you mentioned last Friday?
That speed equals, or velocity, wait, gosh, it was either speed equals instantaneous velocity or velocity equals instantaneous.
Yeah, related to that. So
It was absolute value of velocity.
Okay.
speed is the absolute value of velocity.
Okay.
Okay, but she had it.
I got it right.
Yeah, she got it right. She got it exactly right Friday, and it kind of got a little fuzzy over the weekend, but that's the way things work, right? Okay, here's a list here
I like it.
that kind of tells us that it's a guide to what is happening. And so it's just nomenclature, really. Okay, velocity, average. So velocity, average velocity is position of B minus position at A over B minus A. So the change in position over time. And acceleration is V prime of T, or A of T. And so this is just an acceleration, the average acceleration is going to be velocity at B minus velocity at A over B minus A. And the particles is stopped or at rest when V of T is equal to 0. So that's talks about, and what kind of number did I call that?
Oh,
It's a critical number.
A critical number, thank you. So critical number. So that's the number of evaluation. And then we have left, right, back, or down when V of T is less than 0. And initially, usually it's going to be T equals 0 because that's the way time works, right? You start timing. And then here's what Hannah was talking about earlier, right? Speed is absolute value of velocity right here. Important to remember, I keep on bringing it up because it's one that, with my experience, that people forget a lot. So if I mention things a lot, they just tend to be things that people forget. The speed increases when V of T and A of T have the same signs, either both, either both.
Oh. Either both, speed.
Either both positive or both negative.
Yeah.
That's what we'll say.
Why do you have no brain fart or something?
That's right. It happens.
You just said either both and I was confused.
Yeah, that's fine. That's fine. That's fine. And then, of course, speed decreases when A of T and V of T have different signs. And then we come into a concept of displacement. Displacement is the change in final position minus starting position. And then there's a concept of total distance, the total number of units traveled regardless of direction. And so this is just a list of things that we've in part talked about, but we're going to explore later on here.
Displacement? How is that in regular physics?
Okay, let's see. Okay, here's the analytical process for determining direction of a particle. Of course, we already did this last Friday. So you determine where the particle is stopped or at rest, and then that is finding, like Kylie mentioned, the critical number, right? Setting that V of T equal to 0 and solving for T. And here's an example of what the sketch of that looks like. Create a number line with S of t and V of t. Place the times when the particle is at rest on the number line, in this case 2. And this creates intervals. Then pick test numbers and plug in the velocity to determine the sign, positive or negative. And the cool thing that will really help us, and this ties back into pre-calculus last year, that if you know that this 0, whatever it is, has a multiplicity of 1, you know that you can just find the sign, and then at the next interval, that'll just change places. So if we know the multiplicity is 1, for each of these zeros, we can just say that's negative, determine that's negative. Well, that has to be positive, that has to be negative. So there's a logic for that. And then, of course, then we answer all of our questions. And it says, and justify your answer utilizing information on the table you created. I don't see the table there. You don't really it's using this information right here. I guess that's what I would call a table. And what happens here, when you find this is negative, do you see these arrows below the line? You can draw the arrows because you know this down arrow indicates that the actual function, position function, is decreasing. Down arrow. So down arrow, up arrow, and this is over here, in other words, a down arrow. So you can just go and this will help you to sketch or conceptualize what's going on here. Okay, and now we have worksheet 1, what you need to know about motion along the x-axis. So what I want you to do is go ahead and take a few minutes and just try to fill in the blanks here and see if you can use the last 2 pages to kind of justify. We'll just review this here in a few minutes, okay?
online or if I got it when I was actually like at the academy. It was one of the two. I've had it for a couple of years, that's why I can
Oh,
remember.
really? Have you ever seen me wear my Navy sweatshirt? Yeah. I gotta wear it sometime.
I think so. Remind me of what it looks like again.
I'll wear it, it's really pretty, I'll wear it sometime.
Yeah.
I gotta wear it on, at least on the weekend right before Navy plays Army. All right, let's go ahead and go over these things here. Initially means when what equals 0?
T.
T. At the origin means what equals 0?
X of T?
Yeah, I'm thinking x of t, and really for this purpose I want to use x of t, v of t, and a of t. So we'll just use those whenever we can, all right? At rest means what equals 0? V of t. Oh, very good. And if the velocity of the particle is positive, then the particle is moving to the
Right.
right, and that's assuming we have like a left, right along the x-axis, which is what we usually see. If the velocity is what? Negative. I'll just write neg. To find average velocity over interval, divide the change in what by the change in time? Yeah, x of t, the change of x of t by the change of time. Instantaneous velocity is velocity of a single particle instant in time. If the acceleration of the particle is positive, then the what is increasing. The v of t is increasing. If v of t is increasing, we know the acceleration is positive. And we'll go over this. If the acceleration of the particle is negative, then the velocity is decreasing. In order for a particle to change direction, the what must change signs.
Is it
The velocity, right? The v of t will change signs. And one way to determine the total distance over time is to find the sum of the absolute value. And so we're going to go ahead and examine this problem. It's pretty hard to see here. So we just work out this problem. It's a total distance covered problem. So we have 1/3 t cubed minus t squared minus, is that minus 3t? Yes, minus 3t
Plus 1.
plus 4. Okay, and for this position change, what we're going to do, what I'll show you, what is going to be our first step on this thing? Find our v of t, right? So v of t is equal to, we have 3 times 1/3, and then the minus 1, so we'll get t squared minus 2t minus 3. Does everybody see that? And then next, what's the next step? What is the next step here? To find critical numbers. How do we find critical numbers? So set equal to 0. And then what we do is we try to factor if we can. And that would make our life easier. So then what will we have for this? -3 and positive 4. Well, that's going to be 1. You said 1? 1, okay. So t is equal to 3. And then it says find the total distance traveled on this interval here. We have between 0 and 6. So this is where you set up a table for evaluation purposes. And we're interested in total distance traveled. So what you do is you make your table, and here you put x of t, or let me see, hang on a second. It's t and x of t is what it is. T and x of t. So the numbers we're interested in between 0 and 6. So the first number we're going to put for evaluation purposes is 0. And what's the next number to go into this table? What is our critical number?
3,
So 3 will go here,
and then 6.
and then 6. And now we're going to find distance. So we go to the x of t formula. Here they say s of t. What's going to be x of t where t equals 0?
4.
It'll be 4. So we put 4 right here. And what number do we test next?
3.
3. So we're going to find s of 3 is equal to 1/3 times 3 cubed minus 3 squared minus 3 times 3 and then plus 4.
-5.
So the whole thing's -5? Yeah, so Aaron says -5. Does everybody see that? We got, this is going to be 9 here, minus 9, so that's 0. And then we have minus 9 plus 4, so that's going to be -5, okay? And so how much distance was covered between t equals 0 and t equals 3? Okay. It's going to be 9 units, not -9.
Oh, just distance.
Yeah, because you're looking at absolute values of distance. So find the absolute values here. So we know we covered 9. Yes, the particle went to the left, but covered a total of 9 units. So the absolute value of that. And then if we plug in 6, we're going to see the remaining distance. So, but we know we started at x of t equals 4. So like if this is a big number line here, at t equals 0, I would be here at 4, and then I'd be backing up 9 units to -5. I traveled a negative direction, but the total distance, of course, is positive because of absolute value. So next we do 6. So s of 6 is equal to 1/3 times 6 cubed. And I think 6 cubed is 216 if I'm not mistaken, minus 6 squared minus 3 times 6 plus 4. So 1/3 of 216 is
72.
72. So we got 72 minus 36, which is 36, right?
Yeah.
And 36 minus 18 is 18.
Plus 4 is 22.
Plus 4 is 22. So we went, is that 27 total? So answer would be 27, did it say what units here? No, 27 units total. Okay? Now what's going to be the displacement between t of 0 and t of 6?
Wouldn't you add 27?
Oh, excuse me, 27, it's going to be 27 plus 9, 36, sorry. Yeah, thanks for that. that'd be 36 total, sorry. Yeah, thanks for catching that. Yeah, both of these positive distance, okay. All right, what is the displacement between T of 0 and T of 6?
Would that be 18?
18 units. So that means that the difference from starting position and final position is 18 units, but the total distance traveled is twice that because you went back and forth, right? So anyway, that's typical of what we're going to be doing here, all right? Okay, next. What I want you to do is go over this worksheet 2, and can you see that pretty well on your paper? Because it's a little bit,
Yeah, I can see it.
see it, okay? So go ahead and work this one out here. Aaron, are you working on this?
I'm trying.
Yeah, that's, yeah.
Gavin, are you working on this?
Oh.
How would I,
Are you working on this?
how would I like explain it in a good way? Like I know it's moving
Which
left.
one are you talking about?
The first one, it's moving left because it's negative, but I don't just want to put it because it's negative. Like how do I? Because
Okay, yeah, the only, what you said is just fine, except don't try to avoid using the word it.
I put VFT.
V of t.
Zero.
V of t is less than 0, huh? Or V of t is negative, yeah. That's one thing we have to, that's one thing in the calculus training, we need to try to stay clear of saying it. Now, I've seen people get around that in calculus classes. What they'll do is they'll say, on the sketch, they'll put f of x equals it. And then,
That's genius.
and that explains. So I've seen people get around it that way, but
That's smart.
yeah, so anyway, at t of 0, is the particle moving to the right or to the left? What is your answer for 1 going to be?
Left.
Okay, left. And why is that?
VFT less than 0.
Because V of t is less than 0. You say V of t is negative. Okay. 2, is there a time during the interval from 0 to 12 minutes when the particle is at rest?
I think yes, because 0 is in between -3 and 2.
Yeah, so what we'll say is that you could say that 0 is greater than V of 0, but less than V of 2, right? And I really appreciate that in your last test that you had articulation. What's the last thing we need to put in here to justify here? According to IVT, there must be such a time. Must be a time when V of t is equal to 0. Okay, use data from the table to find approximation for V prime of 10 and explain the meaning of V prime of 10 in terms of the motion of the particle. Show the computations that lead to your answer and indicate units of measure. How would you find an estimate approximation of V prime of 10?
Which,
I don't know, I'm lost.
Okay, let's go back here. Let me show you something. And this really should tie in here. Okay, it's right here. Okay, do you see that?
ah,
Oh.
So we're not going to be able to get the velocity because we don't have, the table doesn't include velocity at 10. But what can we do to find? We can find an average velocity, can't we? So let's go ahead and do that. Actually, it's going to be V prime of 10. Okay, approximation for V prime of 10. So what will we do for that? V prime of 10 is an estimate of what? It's estimate of or we'll say estimate of V prime of 10 equals estimate of acceleration at 10. And what that is going to be is we have this right here. I'm trying to see what those numbers are here. Is that 5?
yes.
Okay. So we have f of b minus f of a over b minus a. So I'm going to get negative 2 over 4 equals negative 1/2. And that's going to be what units? Meters per, yeah, meters per minute squared. And again, it's an estimate. Okay, it says let A of t denote the acceleration of the particle at time t. Is there guaranteed to be a time t equals c in the interval such that A of c is equal to 0? Justify your answer. Is there guaranteed to be a time such that A of c equals 0? There actually is, but can you pick out what evidence you would have for that? Okay, I'll give you a hint. Would A of c equal 0, would that be related to the mean value theorem or maybe Rolle's theorem?
Oh, so it's when it like is,
I was trying to give you a hint. Okay, I'll give you another hint. It'll have to do with Rolle's theorem.
Yeah.
So what do you need for Rolle's theorem?
A horizontal. What do you call it?
Yeah, horizontal tangent line. What tells you you have horizontal tangent line? You have to have a horizontal tangent line here.
Because it goes like this. If it's -3,
Yeah, but what evidence do you have on the table here that would give you the proof for that? Are there two numbers you have down here someplace that are equal to each other?
It's 6 and then 12.
5 and 5.
Yeah, 5 and 5, right? And so here you have f of 6, or v of 6 is equal to 5, so that's your velocity. And then later on, at 12 seconds, v of 12 is also equal to 5. So now the question is there guaranteed to be a time t equals c in the interval
Yes.
such that a of c equals 0? Justify your answer.
In Rolle's theorem, if f goes equal to fv,
Yeah.
it exists for c equals 0.
Well,
Or f is
so what you do, and I recommend really, I said Rolle's theorem just to be more specific, but you could also use mean value theorem, okay? So you'd say since v of 6 equals v of 12 equals 0, according to, and at this place you could say mean value theorem or Rolle's theorem, but I'll say mean value theorem. There must be a time such that a of c equals 0. A time when a of c equals 0. All right? Okay, let's see here. I think that's in there. Okay. Let's go on here. Okay, we'll be okay. Let's see what's hitting us next. Okay, so we got an exercise to work on tomorrow. We'll leave it at that. We'll come right back here tomorrow.